Hi class, this is the second video of Process Capability Index CP and CPK. As mentioned in previous video, the CP indicate that measure how close the process is running to its specification limit. That means the voice of the customer. Larger index is required so that the process will produce the product will not be outside the specification limit. Therefore, the CP is defined as the ratio of the specification tolerance over the actual process tolerance. Today, I will introduce, beside the CP, we need another index to measure our process capability is CPK. CPK is ratio of distance from the process center to the nearest specification limit divided by 3 sigma. This is a graph represented in the last video. That means these have the criteria. This is a case 1. That means fulfill the requirement. Then case 2. Process variable same as a specification limit. Then case 3. Specification limit lower than the process capable, process variable. Therefore, your process not capable. This is the ideal condition. This is a desired conditions. We also maybe sometimes you will produce the product which the mean of your process is not same at the target of your customer. This is your target of the customer. That means the center of the specification. Maybe your average, your mean from your process product from your process is not achieved with the customer target. How to calculate how far your mean to the target of your customer? We use CPK to calculate it. So in this condition, they have 3 conditions here. We will notice that the CP is same for these 3 conditions. That means your process always produce lower variable. Why I say so? Because your process is between the UCL and LCL. But the mean of your process, that means the mean product, is not meet the target of your customer. So how far this mean to the target, to the specification limit? Because CPK. So the ideal condition we need to get is this ideal conditions, which the CPK is higher only when you meet the target consistently with the minimum variable. Minimum variable CP highest, CPK highest. That means meet the target within the USL and LSL. So this graph is clearly represent the CPK. That means your mean of your process. How far your mean of your process. You produce the product. How far your mean of the product to the specification limit. We call it CPK. CPK divided into 2. One is CPK PU. That means the upper one. CPK CPL lower. So this one to the lower divided 3 sigma. Because your graph here is 3 sigma here, 3 sigma here. Therefore, total up becomes 6 sigma, which mentioned in CP before this. So this is the formula for CPL and CPU. How far the mean to the lower limit divided 3 sigma, we call CPL. How far your mean to the upper limit divided 3 sigma, we call CPU. The sigma same as before, we're using range to R bar to calculate it or using standard deviations. This is a single site specification. We also can using double site specification. This formula is same. You notice formula is same, but we only select You only select the minimum number here. So the minimum number represents your CPK. Okay, you can using both single side or double side. It's no problem. If you're using double side, please choose the minimum number only to represent your CPK. Process centerings. That means this one is almost same with the previous graph, but this one is I can explain more detailedly. CP and CPK is equal. That means they are meet the requirements and meet the mean of the target, your mean of your processing and the target of your customer. So the CP is equal to CPK. When your CP is not equal to CPK, that means your graph is shift to the right or shift to the left. Okay? If your CPK is equal to 1, that means your customer requirement is still with the tolerance of your process. Here is the difference. Here still got some distance here. That means this is very ideal conditions. Don't have any producer risk or customer risk. They have the limitation, ideal conditions, desired condition, not capable process conditions. Okay, how you illustrate the graph? After you calculate something, so you draw the graph, you have to justify your answer. How to justify? This is an example how you justify your answer. You can explain when the CP have the value of 1.0 or greater than 1.0, the process is producing product capable of meeting specifications. As you notice that when your CP, which customer tolerance is higher than the process tolerance, the numbers will be greater than 1.0 or equal to 1.0. That means your tolerance is same for customer and process. So this is a capable conditions. The CP value does not reflect the process centering. This is a limitation for CP. Therefore, you have to calculate another index for CPK. When the process is centering and lower variations, the CP is equal CPK. Okay, must be equal. So when the CP equal to CPK, that means the process centering. When the CP is greater than or equal to 1, the CPK have the value 1 or more. That may indicate the process is produce product that can fulfill the requirement of the customer. When the CPK have value less than 1, indicate that the process is producing a product that do not convert to the specification. A CP value is less than 1, indicate the process is not capable. CPK is not centering, then CPK is not capable. A CPK value is 0, indicate that the process average is equal to the specification limit, because you're using mean minus LSL divided 3 sigma. If your process is represent 3 sigma, then the specification limit is the UCL and LCL. If they are equal, the CPK should be 0. Therefore, the process average is equals. A negative CPK value indicates that the average is outside of the specification limit. It's not clear when you put in a sentence and quite blur. Never mind, we'll go for the graph type. This graph is represent clearly what is a CPK stand for. The CPK is the centering of your process capability. Therefore, the CP if get the negative number, that means your 3 sigma, your process capability tolerance is higher than the specification limit. Therefore, your process graph will be shift out of the customer specification limit. This is the customer specification limit. UCL and LCL should be here. Then your process, you produce the product is out of the specification limit. That means it's not center. Center is here. Your mean is here, the center is here. So you will get a negative because it's out of your process. When you get 0, that means the mean is equal to one of the specification limit, either here or here. Okay? When you 0 and 1, that means a side. One side is out of the limit. Then CPK equal to 1, that means there is a desired. Your process is at the centers, and same with the customer specification limit. If bigger than 1, that means your customer requirement is higher tolerance than the process tolerance. Okay, I hope you understand after we present this graph. Let's do some example regarding the CPK. In a process filling box of the rice, where we measure the weight of each box, the process average, that means the average of each weight of the rice is 210 gram. The specification range is between 198 gram and 214 gram. This is the specification limit of your customer, and the standard deviation of the process is 2 gram. That means the sigma. Calculate the process capability index. So how we calculate it? This one is using single CPK calculation method. CPU is the upper, so we use the upper limit of the customer minus your mean of your process divided 3 sigma. So the value is here 0.666. Then the lower limit is using the mean minus 198 divided 3 sigma, you get 2.0. So the CPK is only considered the minimum value between the CPU and CPL. So 0.666 is the answer of CPK. What is meant by 0.666? 0.666 is the distance of your process to the specification limit. So this is a specification limit, lower specification limit, upper specification limit. Your graph will be like that. This is your mean of your process. So the distance here is 0.666. The distance here to here is 2.0. So this is not capable because this is a defect. Therefore, we conclude that the process is not centering, then it's not capable because there is out of the specification limit. Then it cannot meet the customer requirement. Understand? Last index is a process performance index. Process performance index is represent how well your process after period of time. That means when in the short term capability, maybe it's capable, but after period of time, the performance of the process become outlier. That means it's become not capable anymore. So we have to calculate for the long-term capability with different index, which is PP. But the calculation is same. Only the data is different because weekly data become yearly data. So the data will be highest. So same as PP and PPK, same formula using same method to calculate. It's very easy to understand. The illustration for each condition also same with CP and PPK. I believe that you can understand yourself here. It's same explanation, only the data difference. So this is a performance. Maybe short term is under control. After long term, the variable will be highest. So the target of the long-term performance is same as the short-term performance. That means the PP and PPK should be same as CP and CPK. So the conclusion for this video is, if you want to know the variable of your process in the short term, we're using CP or long-term PP. Then need to know the process how close to the specification limit, CP, K or PPK.